All right, and welcome to section 4. Most of the stuff you're going to be doing in this section, you should be able to do kind of on your own at this point. I'm hoping that you're building the independence of starting to understand what's going on with these functions. You will need a calculator with this one, so if you don't have one, pause the video, take a moment to make sure that you have one. So for this one, let's just take a look at a soccer ball kick from a player 3 feet off the ground at an initial velocity of 35 feet per second. First thing we're going to do is create the function rule. So we're going to go use our function rule, the h equals. It starts at 3 feet off the ground, goes at 35 feet per second, and decreases at 16 feet per second squared. So we're going to plug that into our calculator over here. And what you'll notice if you go to graph it, it may or may not appear on your calculators. And what you're looking is you're looking to make sure that it kind of fits on the screen so that we can use this. So what we're going to need to do is we're going to need to go to our window, our zoom function. And let's start with just zoom standard so we're all on the same page. So let's just go to 6 and go to zoom standard. And you notice it's kind of a mess. This does not look like a soccer ball being kicked. That's because we haven't really set it up. So if we go to our window, keep in mind our x is our time. So I'm going to start at 0 seconds. And then, this is where kind of a guess and check, but an educated guess and check. If you were to kick a soccer ball as hard as you could, how long would it be in the air? A couple seconds. So not many more than 5 seconds. I'd be shocked if anybody could kick it in any more than 5 seconds. Now the y values tell us how high it goes. So we know it's going to land on the ground. It starts at 3 feet, but how high does the soccer ball go? I don't know. Let's just guess 25 feet up in the air. And what I'm doing here is I'm setting up a window so when I go over the graph, now I can see what the window looks like. So now here's me kicking a soccer ball. The bottom here, our x-axis, is going to be the time it was in the air. So it's going to be a little more than 2 seconds in the air. And then here's our height. It's 25 feet at its highest. So it looks like it's going 22 to 23 feet. So if we want to find out how long it will take to hit the ground, we're going to go to our calculate screen. And the ground is where it hits 0. Again, so what we're going to do is see where it says a 2.5. We're going to move the little Spider-Man thing over here to the left until we see it. Hit enter, and then move it to the right, and it's going to find the 0 in between those two lines, and it's at 2.27 seconds. Okay, so it's a pretty good estimate. What's the rate of change from the ball from 1 to 2 seconds? Well, if we want to do rate of change, remember rate of change is y2 minus y1 over x2 minus x1. So from 1 to 2 seconds, it goes 22 to 9 over to 1 minus 2 seconds. So the rate of change from 1 to 2 is going to be going down, and 22 minus 9 is going to be 13. And that's going to be our rate of change. When would the rate of change be negative? Well, anything after 2.7 seconds, or if we're going to go to our graph again, what we need to know is what's our peak? Because anything before the peak is going to be positive rate of change. Anything after the peak is going to be negative rate of change. So let's find that maximum value. Let's move over here. Let's get our little Spider-Man thing over here. Then move it to the left side first, right side second, hit enter. 1.09 seconds, so about 1.09. So after the 1.09 seconds. So the first 1 second or so, it's going to be going up, then it's going to go back down. So the domain of the function is our x values, and that's going to be, so our x is going to go from 0 seconds to, we said it hits the ground 2.27. That's going to be our domain, because remember the domain is the x values, and the range is going to be a maximum of 22.1. If you look over here on the calculator, it's going to go about 22 feet in the air. So it's going to start at 0 feet and work up to about 22.1 feet. If you kicked it from ground level, how would it change it? Well, overall, we don't have to go back and recalculate this. What you would know, if you kicked it from the ground level, it's not going to be in the air as long, and it's also not going to reach the maximum peak. This whole graph is going to be shifted down about 3 feet. So its maximum height, instead of 22.1, be around 19.1. and it would take less to go up in the air. So it'd probably land somewhere, around 2 seconds instead of 2.1 seconds. So hopefully this gives you an idea of how to play with a calculator, work the function, go back and forth for these problems. Best of luck. Let me know if you have any questions.